Hi, welcome to our continued focus on science. So last time we took a look at what's really going on with the language of science and what are the hidden challenges that English language learners encounter there. This time we're going to talk about culture, the impact of culture. And I have a feeling you're either absolutely going to love this lecture or you're going to hate it. It's kind of fluffy. There's not a whole lot to hold on to that tells you what to do on Tuesday. But what I'm hoping is that I'm going to open your eyes, if they're not already open, to how there is a culture of science. There's definitely a worldview that we're being asked to buy into with science that may or may not perfectly match with what students walk in with. So anyways, we're going to spend, I don't know how this will go, but I'm going to spend some time kind of walking you through this. There's actually a handout. I'd like you to have it with you, have it so that you can see it. I think this lecture will make a little more sense if you can access that, either on another screen or as a printout. So I'll assume you've got it. So I think the place I want to begin to kind of understand the role that culture plays in science is something that I've thought of from time to time. And that is, we're all born with basically the same senses. I mean, some of us can hear better than others or see better than others, and some of us are born without a certain sense. But for the most part, we're all pretty much built the same. And so why don't we all have the same scientific beliefs, right? Because science is just about taking in data through your senses about the world. And I think that it's a key question because the answer is the answer to where the challenge is for English language learners. That yes, we do take in information all the time through our senses. You're taking in information right now. But it only makes sense to us when it kind of enters our worldview, when it gets caught up in our web of what we value and what we notice about the world and what we care about and what we believe about what's true about the world. So the sensory data that comes in for us, whether it's through our eyes, through whether we're observing something, whether we're hearing something, whatever that is, it only begins to be knowledge. We only use it to make knowledge when it meets our worldview. And we tend to fold in that which kind of matches up with our worldview and reject that which, and often not even notice that which doesn't. And so, so when you start to think about how we build scientific knowledge, that it's not simply the senses, it's data coming in through the senses and then being made sense of through the worldview, you really start to get a sense of how important culture is in your classroom, right? Because every student sitting in your classroom is probably going to have a slightly different worldview than the people around them. Even if you have, say, 3 predominant cultures in your classroom, you and I both know that culture is a big thing and that family cultures and an individual kind of buy-in or opt out of culture is very complex. And so every student has kind of a working worldview that's probably slightly different than the people around them, but more like others from the same culture, for example. And so, so when we are creating scientific knowledge, we are actually we are taking sensory data and we are building knowledge out of that which is meaningful in our life situations and that makes sense in our worldviews. And so it's what we are doing is we are using our sense of how the world works, and we'll take a look at that in a moment, some of the dimensions of that, but how the world works And we are interpreting everything that we see, hear, experience through that. And that's what we normally do. And I think it's important to take a look at the word heretic. So the word heretic, it doesn't necessarily mean someone who goes up against a religious church. What it means is someone who interprets data they reject the communal worldview and they opt into their own. So they're rejecting interpreting scientific data, interpreting sensory data through the shared worldview, and instead they're going with their own. And so it kind of, for me, when I think about that, I realize most of us are not heretics, right? Most of us are buying into the worldview that we were usually born into, raised with, educated in, and so that means for the students in your classroom that their web of knowledge, their worldview that they come with, that is fully operational in your science class. So no matter how amazing the data is that you're putting in front of them, no matter how amazing the lab experiment you have them carry out or that you demonstrate to them, or the YouTube video that you have them watch, they will interpret it not necessarily the way that you want them to, because it depends on their worldview. It depends on this kind of communal, and often it's cultural, system of ideas that they have about how the world works. And that is what they use for making decisions about whether or not to reject the beliefs that you are giving to them. One thing I want to mention is that in classrooms, especially where students are not carrying out a lot of inquiry, it's very possible that students look like they're learning science, and they look like they're taking on the beliefs that you're hoping as the teacher that they take on about how the world works, but they may be simply giving back memorized information. And I think that's been true for me before as a learner of science. There are some aspects of science that I still can't wrap my mind around. And I think it's not necessarily just because of my my culture, English speaking, rural, US, now it's urban Spokane culture, middle class, educated, that kind of thing. But through the aspect of culture that's just your own lived experience. So for me, every room has walls, and every, say, farm has edges, and I've seen the edge of land where it hits the Pacific and the Atlantic, right, and the Mediterranean. I can't imagine limitless space. I just can't go there. Did I flunk that part of the science classes I had to take? Absolutely not. I was able to regurgitate exactly the right facts. So one thing I want to highlight for you is that students' web of understanding is fully operational. It's what they're using to interpret the sensory data you're putting in front of them. And they may sound like they're buying into it, but they may not be actually getting it. So there's kind of those two levels. So I've got, let's see, on the handout that I want you to take a look at, I created this, I grabbed a picture of a classroom off of Google Images, and A is just, what a typical classroom might look like. It's not a lab classroom. But a typical classroom might look like a teacher looking out at empty desks, assuming that all students are starting from the same place, essentially, and learning, say, chemistry or physics. And what I did with the second picture, the B picture here, is to to put different colors of dots on desks as kind of a visual reminder that students might have radically different beliefs as they're sitting there next to each other. And so actually, it may look like your work is to convince everyone in the same way that gravity works in this way, but you might actually have a lot of different challenges on your hands, and including from the native English speakers, because everybody's walking in with those lived experiences and with their cultural worldviews. And everybody's families participate in different kinds of communities in different ways. And so the really big picture that I want you to take away is that when you look out at your students, when it's time for science, or if that's all you teach is science, is that you've got quite a challenge on your hands, and that is to learn about where your students are starting from. What are their starting assumptions? What are their values? And then doing some work to figure out how those are going to impact their interpretation of the sensory data that you're going to put in front of them. One thing that I think you might be tempted to do is to think about students sitting there watching the world's greatest lecture on science, the world's greatest demonstration of a lab, and coming to a different conclusion than the one that the textbook and the teacher are hoping the students come to, and seeing it as some kind of problem of the students. And what I wanted to do at this point in the lecture is to kind of highlight for you, it's actually a universal human problem. One thing that has fascinated me over time is when someone makes a new discovery in science and other scientists come out and almost bully that scientist. They refuse to publish the articles of the scientist, or if they are published, scientists come out and write scathing reviews, or they attack them at conferences. I don't mean physically, but they attack them at conferences, that kind of thing. And they really resist this new idea. And then what happens over time is a few more people accept it, and then a few more people, and then a few more people, and then, ta-da, we're in a new era, a new epoch, right, in science. And so we take this step. And that whole process, it's the same thing going on for students. We have a worldview that we're tied to. It's the way we interpret sensory data. And when an outlier, what looks like an outlier comes, we want to ignore it. We want to downplay it. And we certainly don't want to change our worldviews, our scientific understanding because of it. And I thought of a couple of examples. Galileo, in terms of, does the Earth circle the sun, or does the sun circle the Earth, right? That kind of thing. So Galileo had an idea that was firmly rejected by those around him, and it was a time at which you could get in great big trouble for your scientific beliefs, and he did get in that trouble. And if you think about it from people's perspectives at that time, this radical idea that the Earth rotates around the sun, there's a couple of things that would complicate accepting that idea. The first one was there was a very set worldview about the order of things. And this was sacred, right? This was looking at the sacred order in terms of gods and other things. And so people bought into this, and it helped them make sense of their everyday life. And it helped them make sense of what was going to happen to them after they died, that kind of thing. So this was tough to give up. But their everyday experience was of them moving on the earth and seeing animals and other people and ox carts moving on the earth. Not the earth moving, but people moving on the earth, as if the earth was kind of the thing that never moved, that kind of thing. And so when you think about it from that standpoint, it makes sense that, yeah, that was a big bump to get over, right? That was a huge worldview interruption to really kind of accepting what that scientific data was suggesting. And Galileo was truly a heretic, right? Because he was not willing to take this communal worldview and interpret the data, but rather he wanted to try out a new one, which only he, for the most part, subscribed to. So that made him a heretic. A more local experience that happened, is it 20 years ago now? 30 years ago? Long time ago. 20 years, I guess. 20 years ago was the discovery of Kennewick Man. So there was a boat race on the Columbia near Kennewick, and two boaters discovered a skull, and they turned it over to the authorities. The authorities discovered that it was not a recent death. This was old. They sent it off to someone who was an archaeologist, and that archaeologist discovered it was 9,000 or 10,000 years old. Now, that wasn't problematic, or you wouldn't have thought it was problematic, that data coming in, except up until this point, scientists had a very firm worldview that people came across to North America in three groups, and they were all related racially, these three groups, and they came across in a very limited time span a band of land that was across what's now called the Bering Strait. And so in exploring the data around Kennewick Man, who was he racially, who was he related to, how did he end up at that time period in the Kennewick area, that kind of thing, it caused a lot of trauma in the scientific community. And so what you see is a big rejection, sorry, my phone. You see a big rejection by the scientific community of that idea, of the data, of the archaeologist, and now it's fully accepted. And so that's another great example that this is not a student problem, this is not a belligerent 7th grader problem. This is the way we make sense of sensory data. This is our process, our human process. And so I'm hoping that what happens with that is that you get a sense that this is the way we roll. And that means that you, as a teacher of science, that has to be the way that you roll as well. Okay. So on the handout, let's go back to that handout. The second thing that I have there on the handout, and I've taken it from an article called Contextual Constructivism, the Impact of Culture on the Learning and Teaching of Science. It's a wonderful article. It's one of many that really kind of helped me get ready for this lecture. I'm not expecting you to read it, but it is waiting for you in the modules if you just want to take a look at it. Who knows, maybe you love this lecture. You can't get enough of the idea of the kind of the anthropology or the philosophy or the culture of science. And so have at if that interests you. But the reason that I included this excerpt from the article is it gives us some questions that can help lead us in an understanding of the kind of the cultural context that we're all operating in our classrooms. The first question is, what do teachers and students believe about the world around them, especially the physical world? And notice that it says teachers too. So we need to take note of what our assumptions are. Chances are your assumptions and your experiences and your worldview doesn't perfectly match up with the science textbook that you've been assigned to use. And so you need to take note of what your starting place is as well. And of course, finding out where students are gives you a sense of what's the lived experience that they've already built up, that if I don't address it, it's going to counter this sensory data and it's not going to lead to a change in their worldviews. An example, one day I was driving two of my children, our third and in our fourth, Ike and Caroline, and they were having a very lively conversation in the back seat, and I wish I would have taped it. And the conversation was about whether the sun is hot or cold. And obviously one of them, it was probably Caroline, this had been addressed in science class. So at that point she was probably in maybe second grade, and Ike was in kindergarten, or maybe she was in third. And so they were having a lively discussion that the teacher had tried to convince her that the sun was hot. Now, you'd think through a child's lived experience, that one wouldn't be too hard, right? Because when the sun's out, they get to go outside, they don't have to wear as many clothes, they get to go swimming. We say the water is warm, the air is warm. But they were convinced that the teacher was wrong, because both of them had traveled with us when we had gone up to the top of mountains. And they knew that the farther up we went, the colder it was. And often, even in summer, when we went to the top of a mountain, there would be snow. The top of the mountain was closer to the sun than the bottom of the mountain. So the top of the mountain, closer to the sun, was colder. Thus, the sun was cold. And so I'm hearing them move through this, and I realized that probably Caroline's teacher was pretty sure that he or she was successful in teaching this concept to Caroline, that the sun is hot, but she had completely rejected it. But listening in on the two of them behind me talking, I realized that they had a specific reason. There was a concrete reason that they believed that. Had the teacher taken the time to find out what Caroline believed about the sun and how she made sense of that, the teacher would have had something to counter. The teacher would have had a way to kind of address that difference in worldview. So I thought of that example when I came to that question. The second question that's there is, how do students and teachers understand their own place in the world, especially their relationship to the physical world? So those are the two questions I wanted to focus on the most. So finding out how your students, how they believe they fit into the world, what is their role, having a sense of that, because it's very likely that there might be some things that you are presenting students with that'll go up against the role that the student thinks they have in the world. And so they will, just like Caroline, reject that. Okay. And so there are some categories, I wanted to read them off to you. There are some categories that a fellow named Kearney in 1984, he came up with. He was looking for, if we're going to pay attention to the differing beliefs that our students approach our science teaching with, what are those categories that we should be investigating? He came up with several. Self, who students think they are and their role in the world. Non-self, what do they see as not them? Classification, how does the student view how we classify things? And how does the student classify things? Relationships, how does the student make sense of the relationships between living and non-living things? Causality, how does that work? How does cause and effect work? Time and space, how does time work? How does space work? And I've already mentioned to you, a lived experience part of my worldview I cannot let go of is this idea that space is finite. I have never been able to change my worldview that there could be such a thing as infinite space. And so that's a great example. But those self, non-self, classification, relationship, causality, time, space, and especially those first two questions that I read to you, I think those are a fantastic way to start thinking about the kinds of questions and the kinds of, what should your KWL chart, the what I know, what I want to know, what I learned, what should that K look like, right? What I already know coming in and what I want to know. What should that look like? I've also got something, it might look a little scary and a little complicated, but at the bottom of that handout, I have another table that I took from that same article called Contextual Constructivism. And this is taking those basic categories, just slightly changed, and looking at, this is very helpful, giving us a sense of what is the scientific worldview, right? If your worldview perfectly matches up with the scientific worldview, how would you feel about what would you believe about these things versus how might your worldview work? And some of these have big scary words. I think I can explain the ones that matter. So for example, how we think about the other, that which is not us. Science often approaches from a materialistic viewpoint. In other words, what can we see? What can we hear? What can we taste? What can we witness? Also, often it's reductionist. So instead of looking at all the complexities, creating categories and reducing the differences between something. So we can talk about all pine trees or all fawns, that kind of thing. It also can be exploitative. And so science has many times over history taken advantage of people and ecologies and animals to find out answers to things. And so science can be exploitative. Students might be coming in with worldviews that really go against some of these elements. They might have religious viewpoints that very much could never take advantage of humans or even see humans as something that could be a part of an experiment, for example. They might approach from an aesthetic viewpoint. So what matters to them is not measuring of things, but how beautiful things are. They might approach from a humanistic or a holistic viewpoint where they cannot imagine things not connected with other things. There's a quotation in that article, the Coburn article, where a student who must have been one of the writers, the author's students, said that a person who doesn't have a neighbor is not a person. And this was a student who was approaching U.S. schooling from a different cultural viewpoint. And so that's a wonderful kind of holistic approach. Instead of being able to reduce a person to just this one thing, you can't even see, it's not even possible to imagine who a person is without other people around. So that's a very holistic view. Causality, science approaches from a teleonomic. What does that mean? I had to look it up. Teleonomic means being able to see the laws of nature at work and being able to notice them, being able to see them. How might someone's worldview differ? It might be teleological. What's that? Well, you still see those laws of nature at work, but you see them as part of a bigger system. There's a purpose. There's some reason for all of these laws at work. And that very much flies in the face of a lot of scientific material. And also with causality, there's very much a focus on, when you're studying cause and effect, you're looking only at material things, whereas students might come in with more of a mystical viewpoint. They're able to reach outside what is seen and heard and tasted to make sense of what's going on. Around relationship, science often views relationships between things in what they think of as an objective viewpoint and non-personal. And students are often approaching from a worldview that's more subjective. So they are using their opinions and their experiences to value or devalue something. And they are bringing in the personal. And the self, the way that the self is viewed. Science views the self as independent, but my example around the student who believed that a person can't be a person if they don't have a neighbor, that's a great example of a different view of the self. It can never be independent. In fact, if it's independent, it's not a person, right? So you've got dependent there. And intuitive, relying on the role of intuition and having a sense about things, not just the rational, what you can point to and write about in a lab experiment. And time and space are seen as very abstract in science, and I've already told you I just can't follow science there. Not that I don't want to, and not that I didn't get the right answers on all those quizzes and tests, but I just can't quite imagine it as a person. Alternative views come from our lived experience, and that is time and space as tangible. They are something that we participate in, something that we have true experience of. So what I'm hoping, first of all, I'm hoping you didn't hate this lecture. I'm hoping that this has maybe opened up a little bit of a corner of the world that you hadn't thought about a lot. Or if you have thought about it, it's given you some words that you can talk about it even more. One last thing I wanted to talk about are what are the kinds of questions we can ask ourselves around our science teaching. So we'll look at pedagogy next time, but I wanted to start us off, leave this with just a few questions. I think we obviously need to be aware of our own worldviews, right? Our worldview, the worldview of the textbook and the curriculum, and the worldview of every one of our students is going to impact what happens in that classroom. So we really need to start with ourselves. Are we aware of students' worldviews? What I'm hoping is that, I don't even need to mention that at this point, you're fully convinced that that's part of your work as a science teacher. One thing, and we'll take a look at inquiry learning next time, but are we teaching by inquiry? Inquiry starts with what students' assumptions are, what their questions are, and very much it's often designing experiences by them, so they are figuring out what would convince me whether the answer to this question is yes or no. What data do I need to see? And then they design that experiment and they're carrying it out. So I think you can see that inquiry might be one of the most beneficial tools we have as a strategy for English language learners in our science teaching. And then another question, do students feel a locus of control? And I connect this with inquiry, teaching by inquiry. In other words, when you're teaching science, are you telling the students what to do and what to now believe? Or do they feel like they're in charge of deciding what to do with that sensory data, how to make sense of it of their worldviews, and whether or not they should take the step of setting apart something that they've accepted in their worldview and instead replacing it with a new idea, which is pretty radical. That's what science learning is. So we need to be asking ourselves, do students feel like in our classroom that they actually they're driving that process? It's not just us with our science textbook, but they're actually driving that process. Okay, so there are some textbook chapters waiting for you to take a look at and look for any evidence you can as you're reading about ideas that you can gather about how we might incorporate worldviews, incorporate cultures into our science teaching, take those into account and respond to them. And there's also a few other things, just in case you're interested. I put a link in your module that looks at the Kennewick Man controversy. I put the Coburn article as well. And so anyway, so those aren't necessary pieces you actually need to really pore over because you've got a lot of textbook chapters, but they're there if you would like to read them. Okay, after you do all that, I will meet you in our discussion and we'll talk about the culture of science. Okay, see you then.